All right, we're going to review some concepts from last year. So we're going to look at lines and parabolas. So lines, one of the common forms of the equation of a line is our slope-intercept form. So we have y equals mx plus b. Sometimes you'll see plus c or plus k, but you will always have the m in the front. And m is our slope of the line. And b, our constant, is always the y-intercept. So to calculate the slope, if we're looking at 2 points A and B, and let's just have A at basically x sub A and y sub A, and then we have B, which is just going to be at any arbitrary point, so xb and y sub b. The slope is equal to the change in y, so delta y, divided by the change in x. And this is represented or calculated by just finding the difference. So yb, so y sub b, minus y sub a, divided by the change in x, so x sub b minus x sub a. So that's how we would calculate slope. So now let's look at graphing. If I want to graph these three lines, the first line I can see is already in slope-intercept form. And here I can see the slope, the m value is -1, and the y-intercept is at 5. So to graph it, I'm just going to go to 5 on our y-axis. And then the slope is -1, so that's go down 1 and right 1. Or we could go up 1 and left 1. So I'm just going to do that a few times so that I can have my line. And what you're going to do is take a ruler and line up your points and then just draw the line that passes through them. So that gives me the first line. Now my second line is not given to me in slope-intercept form. So for this one, what I'm going to do, instead of trying to rearrange it, I'm just going to find the two intercepts. So we have an x-intercept. The x-intercept is found when y equals 0. So then this equation becomes 3x minus 15 equals 0. So 3x is 15, x is 5. And then y-intercept is when x equals 0. So that means 5y minus 15 equals 0. 5y is 15, y is 3. So we plot these 2 points. So x equals 5. So on my x-axis, I go to x equals 5 and draw that point. And then I have y equals 3. So I go to the y-axis. Y equals 3 is over there. And then again, line them up using a ruler. And that gives me my second line. The third line just says x equals -4. So whenever you have an x equals something, this is a vertical line. So that means we have x equals -4 and it's a vertical line. That just passes through x equals -4. So those are our three lines. Okay, so now let's look at quadratic functions. We're going to look at vertex form to start with. So vertex form looks like y equals a times x minus p all squared plus k. Now sometimes you'll see x minus h all squared plus k, but regardless of what variable we use in there, the first one will always be an a though. So here, this tells us, it's called vertex form because from here we can see the vertex. The vertex, I'm going to write this up here. The vertex is basically at P and K, or if you're using H, then it will be H and K. Now, A, P, and K tell us something. A gives us the shape. So whether we are happy face or sad face. And it also will tell us if we have had a vertical stretch or compression. Then we have P. So this tells us the horizontal translation. So horizontal translation, if P is greater than 0, so that would mean it's at x minus P, then we are going to the right. And if it was less than 0, which means in the bracket would say x plus P, then we would be going left. And now let's look at K. So here, this tells us a vertical translation. So if K was greater than 0, so it would say plus K, then we are going up. And if K was less than 0, so then it would be saying minus K, then we are going down. Now, for A, there are a few things to consider. So if we're looking at our A value, if the absolute value of A, so meaning just the number and not the sign, if it lies between 0 and 1, then we have a vertical compression. By a factor of 1 over and whatever that A value is, okay? Now, if the absolute value is greater than 1, so basically A is a whole number bigger than 1, then we have a vertical stretch. By a factor of A. So if A is less than 0, basically meaning A is negative, then we have a reflection. In the x-axis. This means that the shape of my graph, so the shape of my parabola, is no longer a happy face, it is now sad face. So opening downwards. So when graphing a parabola, we can use the vertex form to take the vertex and then use the step pattern to determine the other points or some other points to help us graph. The step pattern is going to be A times 1 and then times 3, and then times 5, and then times 7, and. So the way step pattern goes is you start at the vertex, and then you're just going to go over 1, and then up 1 times a, and then we go again over 1, and then up 3 times a. Now it could be up or down, because obviously if my a value is negative, then I'd be going down 3 times a, and then it just continues again. So over 1, and then 5 times a, 7 times a, etc., etc. So now we are going to graph a transformed parabola. We're going to start by listing all of the transformations. So if we look here, y equals x squared, this is our parent function. You can call it parent function, parent graph, base function, base graph. All those words mean the same thing. And then this one, this is the transformed function. So we're going to do this in 2 ways. I'm first going to show you how to graph using the step pattern, okay? And then we're going to graph by graphing transformations. You need to know how to graph by graphing transformations because the step pattern doesn't apply to other functions. It only applies to our parabola. So we want to know how to graph by graphing transformations. So before we use the step pattern, we're just going to list the transformations here. So we can see that our a value is negative, so we have a reflection. In the x-axis. And the absolute value of a is a half, so that means we have a vertical compression. And it's by a factor of 2. And then we see we have a horizontal translation. Now because it says plus 3, that means we are going left 3 units. So notice translations, we don't say factor of 3, it's just a number of units. So left 3 units, and then we have a vertical translation. And that's going up 7 units. First we're going to graph this using the step function. And so the step function says start at the vertex. So the vertex in our case is at -3 and 7. So we're going to start at the vertex, so -3 and 7. And then we go right by 1, and our A value is half. So I'm just going to write out the step here. So we have vertex, and the step, there's our A value is negative half, and we're going 1, 3, 5, 7. So this means over 1, and then that's now, because it's negative half, it's down by half. And then we go over 1 again, and then we go down by 1.5 because it's 3 over 2. And then that continues. So we're over 1, so we can go right or left. So we'll do, but we have to do both. So we go right by 1 and then down by a half. We go left by 1 and down by a half. Then we go right by 1 and down by 1.5. Left by 1, down by 1.5. And then the next one is right by 1, down by 2.5. And then left by 1, down by 2.5. And then it's right by 1, down by 3.5, left by 1, down by 3.5. And so that gives us like more than enough points for us to get our parabola. So that is the parabola of our transformed graph. So we will need to understand how to graph transformations by applying each of my transformations. And that is what I'm going to show you here. So I'm going to rewrite my function. This is the function that we are going to graph. The parent function is y equals x squared. So we start by graphing the parent function. And so we just pick some numbers and we plug them in. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and then it repeats on the left-hand side. So negative 1 squared is 1, negative 2 squared is 4, negative 3 squared is 9. So that is our parabola of x squared. And now we apply each transformation in sequence. So we do them one at a time. So we're going to apply the A value. So A is negative a half. So we are going to graph negative a half squared. So notice that basically this is just multiplying the x squared graph by negative half. That's exactly what we're going to do. All the y values get multiplied by negative half. So 0 times negative a half is still just 0. 1 times negative a half becomes negative a half, and the same thing happens on the other side. 4 times negative half is negative 2. Sorry, negative 2, so we're going to go there. Then we have 9 times negative a half, which is negative 4.5. Okay, so that is now those points transformed, which gives me the first transformation. Now, our translations we can do in one step. So the translations, remember, are left by 3 and up by 7. So each point that I've graphed, I'm going to shift left by 3 and up by 7. So I start at my vertex and I go left by 3 and then up by 7. And that's where I end up. Then I take each point and I do the same thing. So left by 3, 1, 2, 3, up by 7. And that's where I am. And that's where the other point will go. And then you're going to do that to all of the points. And the graph you get should be identical to what we graphed up here. Here we have a few more points, so we're able to go lower down. You may not get the exact same points because we haven't graphed that many points, but you will see your vertex and the first 3 points will all match up. And that is how we graph transformations.